Welcome to yet another video by EduPen channel. So in this video, basically what we're going to be dealing with is vertical projectiles in one motion. So before we continue with the video, be sure to hit the subscribe button and the bell notification icon so that you do not miss any content from EduPen channel. So in this video, basically, as I've said, we're going to be dealing with projectiles. But what exactly are projectiles? So projectiles deals with objects that are either projected, thrown, or shot directly into the air, be it vertically upwards, downwards, or when an object is actually being dropped from a certain height. So there are a few points that you actually need to be familiar with in order to solve problems relating to projectiles. So I'm not going to go through everything, but I'm just going to go through some important points only, and then the rest, if you are interested, you can actually send me an email at atapambadela@gmail.com so that I can actually share the notes with you. So the first thing that you need to know is the definition. So with every chapter you have to know the definitions, because in an exam they actually love starting the questions with some definition questions. So a projectile is actually a body or a particle that is projected or launched, then moves under the influence of gravity only. So in simple words, a projectile is actually an object that is either thrown or dropped into either thrown into the air or dropped downwards from a certain height, and the only force that is acting on it is actually the force of gravity. And then another point that you actually need to know when dealing with projectiles, it's actually acceleration. So you need to know that projectiles actually accelerate at a magnitude of 9.8 meters per second squared downwards. And then the other point that you also need to be familiar with is the fact that we ignore the effects of resistance or drag when dealing with vertical projectiles. So it's not going to be the same as in questions where we actually deal with Newton's second law of motion, where you actually have to consider friction while doing calculations. So in this chapter we do not actually consider friction being there, although it's there, but we do not consider it. So that's that. And then the other point that you also need to know is the fact that if an object is actually thrown into the air, when it reaches a point where it actually comes back to the ground, that maximum height where it actually stops and comes back, the velocity there is actually equals to 0. So for example, let's say this is the ground and you throw a stone into the air, and then there it goes. And then when it reaches this point, it actually comes back to the ground. So when it reaches this height, the velocity there is actually equals to 0 meters per second. So as your projectile actually moves upwards into the air towards its maximum height, the velocity that it started with, it actually decreases until it reaches 0 meters per second. And also the other important point that you also need to remember when dealing with projectiles is that the time that it takes your projectile to move from the ground to its maximum height, and also to move from its maximum height to the ground again, it's actually the same. So if it took 2 minutes to move from the ground to its maximum height, it will also take 2 minutes to actually move from its maximum height to the ground again. So those are the important points that you actually need to know about projectiles. So without any waste of time, let's continue and check the other important things that you need to know. So the other important thing that you have to know is your equations of motion. So with your equations of motion, basically what you will do is that you will find them being given in the formula sheet in the exam. So you don't really have to memorize them and worry about knowing everything about them, so they will always be provided, and the only thing that you need to worry yourself about is knowing how to actually apply them to the situations that you will be given. So you have VI. So VI in equations of motion, it actually indicates your initial velocity, and then also VF, it actually indicates your final velocity. And then change in x is the change in vertical position in meters. So it's actually the distance. And then time, it's actually, t is actually time in seconds. And then change in time is actually a time interval. So you have the initial time minus the final time. So that's the time interval. And then lastly, we also have A, which is equals to G. So A denotes your acceleration, which is due to gravity, which is always constant. So whenever you see A in an equation, just know that you're going to use 9.8 meters per second squared. And the only thing that changes is your velocity. It's your velocity, but the acceleration is always the same when dealing with vertical projectiles. So without any waste of time, let's apply everything that we have learned. So we are told that a ball is thrown vertically upwards with an initial velocity of 10 meters per second. So the first thing that you need to know is to actually write everything that you are given, or in other words, you have to outline the information that you are given from the question. So we know that this is a vector, so we can represent a vector by a point and a line going upward. A line going upward. So we are told that it moves at an initial velocity. So here on the ground, the initial velocity, which is indicated by VI, is actually equals to 10 meters per second upward. And then they say that at this point where the ball is, at this point from the hands, that is actually a distance of 1.5 meters. So a photograph shown is taken when the ball is 1.5 meters above the point of release. So it means it's not at its maximum height. If it was at its maximum height, they would have told you that the ball reaches a maximum height of maybe 2 meters or 3 or maybe 10. So it is, you are just told that it actually at this point it's actually at 1.5 meters. So you need to find your maximum height, in other words. So when writing this vector, you can just draw it like this and then say that at this point it's actually your 1.5 meters, and then extend it further to this point upwards and say that this is your H max, or maximum height. So it means that we actually have to look for this distance. So how much distance it traveled from this height that is shown in the picture until it reaches its maximum height. So we outline the information that we are given. So VI is equals to 10 meters per second. VF, we know that VF at this point where the height is at its maximum, the VF is actually equals to 0, as we have already discussed. So it's gonna be VF is equals to 0 meters per second. And then change in distance, or the displacement of this ball, we don't know. So that's something that we're gonna be actually looking for. So ideally it will be equal to 1.5 meters plus y. So that will be your maximum height if you do it mathematically. And then the other thing that we also know is the acceleration, because acceleration is always constant in your vertical projectiles. So it's 9.8 meters per second squared downwards. So after having outlined everything, you just now have to determine which formula can I use in this problem. So we are told that we should determine the maximum height above the thrower's hand. So you go to your formulas, you say, okay, here on the first formula I have velocity, yes. I have initial velocity, yes. I have acceleration, yes. Do I have time? No. And am I looking for time at this point? No, I'm not looking for time. So this equation is actually not going to help me in any way. And then you go ahead and check the second equation. This equation, I can actually look for change in x, which is the distance. Am I looking for the distance? Yes. Okay. Do I have initial velocity? Yes. Do I have final velocity? Yes. Do I have time? No. It means we cannot use this formula because we do not have time to calculate what we are looking for, which is change in x. So this formula has failed. It means you cannot use it. And then we go to the third formula, which is change in x. Yes, we are looking for that. Do we have initial velocity? We do. Do we have time? We don't. So we cannot continue like checking other things. We don't have time, so we cannot use that. And then the fourth formula, do we have final velocity? Yes, we do. Do we have initial velocity? Yes, we do. Do we have acceleration? Yes, we do. Do we have change in x? That's exactly what we are looking for. It means we have everything except change in time. So this is actually the perfect formula to actually use. So we take the formula. You say number one, Vf squared is equals to Vi squared plus 2a into or multiplied by change in x. So our final velocity, we set it 0. Our final velocity, which is the velocity that the ball reaches at its maximum height, is actually equals to 0. So we're going to have 0 squared, which is equals to our initial velocity squared, which is 10. We were given that one, plus 2 into our acceleration. We said it's constant, so it's always 9.8 meters per second squared downwards. So because of the direction being downwards, we are actually going to put it as negative 9.8 meters per second squared multiplied by our change in x, which is the distance or the maximum height that we are looking for. So 10 squared is actually equals to 100, and then 2 multiplied by minus 9.8, it's gonna be minus 19.6. Just to confirm, 9.8 multiplied by 2 is minus 19.6. That's correct. Change in x, which is equals to 0. And then you're going to go ahead and transpose your 100 to the other side. So it's going to be equals to minus 100, which is equals to negative 19.6 change in x. And then after that, what you're going to do is you're going to divide with minus 19.6 on both sides, and then you're going to be left with change in x, which is equals to 100 divided by 19.6. 100 divided by 19.6, which is equals to 5.10 meters. Therefore, maximum height that the ball reaches is actually 5.10 meters. 5.10 meters. And that will actually be your answer. So for the sake of understanding, before we go to question number 2, let's try an example that is much more simpler without any tricks on it. So let's say you are told that there's a projectile that is actually thrown into the air with initial velocity of 2 meters per second. And the other thing that you are also given, let's just leave it as it is. You are given only the initial velocity of 2 meters per second. So with every projectile, you know that the things that you know is that VF is already 0 meters per second. And then you already know that the acceleration is equals to 9.8 meters per second squared downwards. So you draw your projectile and say, okay, this is my projectile. It was actually thrown into the air, and then this will be a point where it reaches its maximum height. This is H max, or maximum height, and I'm given that VI is equals to 2 meters per second upwards, and it means here at H max the VF is actually equals to 0 meters per second, and I have to find what the change in X is, something that I don't know. So that is actually something that you actually have to calculate. So what you're going to do, you're actually going to do the same thing as we did up there. We have 3 things. We have our VI, VF, and our acceleration. So you can use the fourth equation of motion to actually calculate what the distance is. So you're going to go ahead then and say VF squared is equals to VI squared plus 2A change in X, which is equals to VI, you are told that it's 2 squared plus 2 into minus 9.8, because the direction is downwards of gravitation always, and change in X, and then your VF, it's 0 at its maximum height, and then you have 4 plus 2, let me just put it as already calculated, 4 minus 19.6 change in X, which is equals to 0, and then you transpose the 4, it's minus 4 is equals to 19.6 change in X, which is equals to change in X, and then you divide both sides by 19.6, so it's gonna be 19.6, 4 divided by 19.6, which is 0.71 meters. So that's how simple the calculations can be. I understand that the first question was actually a bit complicated, so some of you might not have actually understood. So this is basically how simple it is to do these calculations. So they will confuse you by giving you the distance like they did in that question. So you should be careful of such, because some people will actually go ahead and use the 1.5 that was given in the question as the maximum height, which is incorrect. So just be on the lookout for that as well. So continuing with question number 2. So before we continue with question number 2, we actually have to write what we have already calculated. So we have calculated our change in X. So now our change in x is actually 5.10 meters. And then we go ahead to number 2. The question says determine the time it takes the ball to reach its maximum height. And then in my head, I'm remembering something that I've learned today already, that it takes the same time for the ball to actually reach its maximum height as the time that it takes to move from its maximum height to the ground as well, or to its initial position. So that is sorted. I know the rules about time. And then, so now I'm actually going to look at a formula that will actually help me to find the time, or to calculate the time that this ball actually reaches the maximum height that I just calculated in question 1. Right. So we go to formula 1. So do we have our initial velocity? Yes, we do. Do we have our final velocity? Yes, we do. Do we have our acceleration? Yes, we do. So can we use that formula to calculate the change in time? Yes, we definitely can. So we take the formula Vf, which is equals to Vi plus acceleration multiplied by time. So our initial velocity, we said it's 10, and then our final velocity it's 0, plus our acceleration, which is minus 9.8 multiplied by t, which is something that we are actually trying to calculate. So we know that we are going to have 10 minus 9.8 t, which is equals to 0. Then you transpose, you have minus 10, which is equals to minus 9.8 t, and then you divide by 9.8 on both sides. So 10 divided by 9.8, it's actually 1.02 seconds. T is equals to 1.02 seconds. So it means that it actually took this ball 1.02 seconds to actually reach its maximum height, where the velocity there is actually equals to 0.